Alright, so like, what is matter? Alright, so there are two types of things in the universe. The universe is made of matter, which is all the physical stuff. That is my hand and this pen and this table and this pepper and this paper and this binder. Just all the stuff you can see and touch. Plus energy. Energy is just like fire and lightning and electricity and all that. We're going to talk about matter. Matter has three. Let's see, these are like three primary things. Mass is just okay. Mass, which is how much stuff is there, and then you have density, which is how compacted is that stuff, and volume. How much space does it take? If I had a balloon the size of my head, they would both be the same volume, but my head has a greater density and mass. My head has more stuff in it than a balloon, and a greater amount of it's all compacted tighter. Anyway, I am going to show you a density demo. Here we have a glass. It is made out of matter. It has mass. It is relatively dense, and the volume is just how much space this whole thing takes up. I'm gonna fill it with something. I have filled it with water. Water is also matter, and all this is made out of atoms. All matter is made out of atoms. More on that later. First, let's add something a bit more or less dense. Now, you can already see the oil. I added some vegetable oil. It is less dense. This is a commonly known phenomenon that oil will sit on top of water. Why? Because, well, water is more dense. It goes to the bottom. It has more weight to it. This is taking up much less space than this. But if I added like this much, it would still be on top. If I added this much, it would still be on top because it is less dense. This oil has less atoms in one small space than the same amount of this water. What about something else? I added barely any honey in there, yet it went straight to the bottom. It is the densest. It is heavier than all of these. And you can see the oil floating back up to the top because the oil is lighter. The atoms in it are less clumped up together. All three of these are going to be made of molecules, but more on that later. First, let's add one more thing. You can see little bits of oil escaping the honey and going to the top. The oil, as I said, is lighter, and so it rises to the top. The lightest molecules are going to rise to the top. The same thing happens in air, in the ocean. What is light rises to the top. But what if we add peanut butter? Let's see how heavy peanut butter is. Get in there. No, don't stick to the side. Is it the heaviest? No. It's floating on top of the honey. The peanut butter is floating on top of the honey. The peanut butter is more dense than water, more dense than oil, but less dense than honey, and thus floats on top of the honey. And now then, so what is all this stuff made of? Well, the fundamental building block of matter are atoms. The smallest bit that is still matter. That is still a thing that you can technically touch and feel and interact with. What's that going to look like? Well, actually, no, that's a bit incorrect. Let me add one more. There we go. So, what I've drawn is a very simple atomic model. An atomic model shows what an atom looks like. And let's get real. They're too small to see. Even with microscopes, they're not really visible. We we can't really. The atoms are too small to see, so we can't have to just guess at what they look like and draw pictures that kind of metaphorically show what they look like. So this is not the only way to draw it, but it's the simplest one. And atomic models are the different ways people draw or make atoms. And you may be asking, what's all these different pieces? Well, this little floaty bit, that's called an electron swirling around the inside. These white ones are going to be the protons, and this little black one is going to be the neutron. And you may be asking, what's the difference between all of these? You probably already learned this earlier in the year, but let me review. The neutron has no charge. There's this thing called positive and negative charge. This has none. This is not charged at all. It's just there. It's just a little tiny thing. It is a part of the atom that just adds weight to it. But what is more interesting are the protons. They are positive, they have weight, and the tiny electrons, which are negative, these are what electricity is made out of. And they just zip around the atom super fast. And there's always an equal amount of electrons and protons. So these two always equal each other. And the number of neutrons always that means not always, but usually equals the number of protons. These all usually equal each other. So you may be asking then, is each and every one of these, they're all made out of atoms? Well, yeah, but not just made out of atoms, they're made out of combinations of atoms. All this is, let me explain. So there's this thing called a molecule, which are atoms connected to each other, atoms bonded to each other. And if you hear the meowing, that is my cat. He wants attention. Now let me see. I already drew an atom over here. Let's draw a very, very simple oxygen atom. That's actually, there we go. I'm going to just put an O within an O. I could draw a whole nother one of these, but that'd be too complicated. So instead, this has an O in it. That has, no. I need two H's. There we go. This is my molecular model. Now, atomic model shows what an atom looks like. Molecular model shows what a molecule looks like. I forgot the what part, but shows what a molecule looks like. This is my molecular model. There are many types of models for molecules because one molecule is still too tiny to ever actually see. They're far, far, far smaller than you or cells or anything living whatsoever. But this is the smallest piece of a water you can get. Water is made out of hydrogen and oxygen, two different elements. And all these are going to be made out of molecules. That means groups of atoms stuck together. For instance, the honey is going to be made out of carbons and hydrogens, but chained, long chains of them connected to each other. Lots of carbons, lots of hydrogens connected to each other all over the place. And the olive oil is also going to be lots of chains of carbons and hydrogens, but grouped together differently. And there'll be some oxygens mixed in there, some other elements mixed in there. The glass is going to be made out of, I believe, lots of silicone atoms stuck together. And this is not at all a good molecular molecule for glass. I do not know what that looks like, but it's going to be made out of its own atoms, and they're going to be grouped differently as compared to the spoon, which is going to be made out of various metal atoms in some kind of complex configuration. Here's a good metaphor. A bunch of ingredients can go into making bread. And when you combine them all, they cease to be what they were. Where'd that peanut butter go? That ought to go in there too. And you may be thinking to yourself, all these are very different. You have oil, you have water, you have honey, I'm adding peanut butter, there's flour, and in fact, I'm going to add a few different types of flour. These are all very different pieces, but when you combine them, they make something completely different. And atoms are the same way. Hydrogen and oxygen are both gases, but when they combine into a molecule, they form water. And in the same way, carbon is what diamonds and graphite in your pencils are made out of. Hydrogen is a gas in the air. When you combine them, you can make peanut butter and flowers, and people are also made out of carbons and hydrogens, as well as a whole bunch of other types of elements mixed together. The point I'm getting at is everything is made out of atoms. Those atoms are combined into complex configurations we call molecules, and those molecules make up pretty much everything. All right, I will see you next time.